Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 6.2.3, part 1 or day 1. This is on checking solutions. So just remember, we go through a process. If you take this equation, 3 times x minus 5 is equal to 15. And either way you choose to solve this, whether you choose to divide each side by 3 to begin, or if you send in the dive bombers, I'm a big fan of just sending in the dive bombers because this can be complicated if you've got other terms on the left side of the equation along with this distributive property section. So I would just recommend sending in the dive bombers to distributive property. Call this 3x minus 15 is equal to 15. Now you can add 15 to each side because you want to zero this negative 15 out, and you zero it out by adding the opposite to it. So that becomes a zero pair, leaving you just with your 3x's on the left-hand side. But whatever you do to the left side, you got to do to the right side. So let's add 15 to this side as well, and that gives you 30. So what do you multiply times 3 to give you 30 for an answer? That's it. Your answer is 10. So now we check the solution. So checking the solution is basically where you evaluate the expressions for this given value of x. So if we think x is equal to 10, we're going to plug it in here, and now we're going to evaluate the expression on the left to ensure that it is indeed equal to 15 when x is equal to 10. So do the order of operations first, the order of operations, which means take care of the parentheses first. 10 minus 5 is 5, and then 3 times 5 is 15. Yes, that's a true statement. That means that we know for sure that x is equal to 10. Now, had you made a mistake and you thought x was supposed to be equal to 2, before you submit or declare your answer, you want to check it. So plug it in, work through the process. 2 minus 5 is equal to negative 3, and 3 times negative 3 is equal to negative 9. That is not true. That means that this cannot be a solution because the solution to the equation is whatever value for x makes the left side of the equation equal to the right side because it's an equation. It says they're equal. So it's no longer a situation where we're trying to decide which side is greater. We know that they're equal. We just need to figure out the value for x that makes them equal. All right, what on earth is all of this? Oh, I wrote it in tiny, tiny little letters. All right, so this is the process that we always use when we are solving problems, when we are solving equations. First one would be to do distributive property. But if your problems don't have any distributive property, move on to the next. And this would be combining like terms. And so on the left side, you've only got one term, nothing to combine. On the right side, you've got an x term and a constant term. You can't combine those. Same thing happening here. You can't combine those. There's nothing to combine there. So now we move to adding or removing balanced sets. And so I typically start with my x's. I choose to collect them on the side with the greatest number of x's. So I can take away 4 x's from each side. That cancels everything out from the left side and leaves me with 2 x's minus 14 on the right side. Now I will try to get my 2 x's all by themselves by adding 14 to each side. That cancels this out, leaving you with the 2 x's and a 14 on this side. And now you ask yourself the question, what do you multiply times 2 to give you 14 for an answer? Well, 14 divided by 2 will tell you what that answer is. That answer is 7. So when we check the solution, 4 times 7, I'll do this kind of mentally, is 28. And 6 times 7 is 42, and 42 minus 14, if that's 28, then we've got the correct solution. 42 minus 14 is equal to 28. We've got the correct solution. We can declare our answer. For this problem, I've already got x's all, or they're not all by themselves, but they are all on the left-hand side. Here we had x's on both sides. I don't have to worry about collecting my x's on one side because they're already there. So now I just need to get them all by themselves by taking away the 5 that was being added to them. And if it helps you to think of it this way, I say this all the time in class. 3x's plus 5 is equal to 50. So we want to know what the 3x's were equal to before we added the 5 in. So let's take the 5 back out, and you'll realize, oh, yes, it must have been 35. No, 45, because 45 plus 5 is 50. So now, go through the same process. 3 times something is 45. What would you multiply times 3 to give you 45 for an answer? Well, if you divide 45 by 3, we'll find out. 45 divided by 3 is indeed 15. So let's check that. Where we think 3 times 15, that is 45. And plus 5 is equal to 50. Absolutely, that was an easy check. We feel confident to declare our answer x is equal to 15. All right, percent problems. 40% students at Pinecrest Middle School have a school sweatshirt. Okay, I'm going to highlight that. That seems like that's important information. 40%. There are 560 students at the school. That's the total, right? So let's just think about this. This obviously is a percent kind of a problem, and we can use the percent proportion where we say part over the total is going to be equal to the percent out of 100. We may not have to use this to solve the problem, but it's a nice tool to have available to us, right? Where we know the percent is 40, so we put the 40 here, and we know that the total is 560. So we're probably going to have to figure out what is 40% of 560. Okay, so how many students have a sweatshirt? 40% of them have a sweatshirt. So when I solve for x here, that will solve the problem for me. Now, let's go ahead and solve this a couple of different ways. First off, my favorite technique when the numbers are friendly is to just figure out what is 10% of a number, what is half the number. Remember, if you could take 10% of any number, double it, or find half of that, you should be able to solve a lot of this mentally. So we're looking at 40%, right? So 10% is 56. So if I multiply 10 times 4, that's 40%. And if I multiply 56 times 4, that will give me my answer, which is what? 56 times 4 is our 224. There you go. 224 students have a sweatshirt. If we set up this diagram, total is 56. I'm sorry, 560. And if we break it up into 10% intervals, each one of these 10% intervals is going to be 56. So 56 plus 56 plus 56 plus 56 gives us the 40%. Because 10 plus 10 plus 10 plus 10 is 40. That's essentially what we just did right there. And then if I use a percent proportion, I'll cross multiply. I'll get 100x is going to be equal to 40 times 560. 40 times 560 is 22,400. And then when you divide that by 100, because we've got to find out what x is, not 100x, then I'll just take that number and divide it by 100, and I get the same answer. So lots of different strategies that you can use here to get to your answer. Diagrams, percent proportions, a little bit of logical reasoning, they're all effective strategies. So if 280 students have school t-shirts instead of sweatshirts, what percent of the school has t-shirts? Okay, so 280 would be the part out of 560. We're trying to find the percent now. If you look here, you'll see that the 280 represents 50%. That's the halfway point. Same thing here, where I took 10%, which was 56, and then 20% was 112. Well, all I have to do really is remember I've already figured out 40%, which was 224. If you added these guys together, you would get 50%. But then you may not know that these two added together might give you 280. So that's where it's probably just best to use the percent proportion. And if you can simplify that, I recommend that you do that, but I'm just going to not bother with that. I'm just going to do the cross multiplication again. 560x is equal to 28000, 28,000, right? Adding the zeros onto there. And now we'll take 28,000 and divide it by 560, and there's your answer. So if we're trying to find the percent, if x is equal to 50, that means that is 50%. And then what percentage of the school does not have a t-shirt or a sweatshirt? Okay. This is implying that students have either t-shirts or sweatshirts but don't have both. Okay, because some of them technically could have both a t-shirt and a sweatshirt, but let's just go with it. So we know that you've got 50% and 40%, which only leaves 10% for the remaining students that don't have either. All right. Letitia wants to get a B+ in her history class. To do so, she needs an overall average score of 86%. So far, she has taken 3 tests. Her scores are 90, 82, and 81. Use the 5D process to help Letitia determine what percent score she needs on the 4th test to get the overall grade that she wants. Okay, so we know how to find an average. To find an average, you add up all of these scores, and then you divide by the number of scores you've got. So right now, her average is what? 90 plus 82 plus 81. 253 divided by 3 is, she's got 84.3. So she's in the B range. She just wants to move up to get into the B+ range. So the next test that she scores is an unknown quantity, right? But we want it to give us an average of 86. So on the 4th test, we're going to have to divide the total sum by 4 to give us 86. So I would tend to use algebra to solve this problem. It's a little confusing. So 5D process, we can do a guess and check. What if she got 90 on the 4th test? Then we would add up 90 plus 82 plus 81 plus 90. That total adds up to 343. We divide that by 4, but that is too low. It's very, very close, and maybe the teacher might have a policy of rounding, but I wouldn't count on it. So let's go up to the next number, and the next number is 91. So when you add 90 plus 82 plus 81 plus 91, that adds up to 344, which divided by 4 is 86. So we can say she has to get a 91% or better on the 4th test to get her grade into the B+ range. Okay? The teacher decided to make the last test worth twice as much as a regular test. How does this change the score that Letitia needs on the last test to get an overall grade of 86? All right, so we're basically, if this one is worth twice as much, then it's kind of like taking 2 tests. So if the 4th test is she gets a 90 on it, then that would be worth 180 points where you'd add in, but you've got to divide by 5 now, not by 4. That would be the part where it would be tricky, okay? So 433 divided by 5, that is actually fine. You can go with the 90, but we're trying to find what is the minimum score that she would need. So 86.6 is too low. So it went down to 88. That was too, no. 90 was too high. 88 was too low. 89 turned out was too high. So it turns out it's a decimal number. If she gets 88.5 on the last test, that would give her the average that she needs. So you can see in a process like this, where it would be really confusing once you start getting fractions and decimals as your answers that you need to declare. Guessing and checking is great when you've got nice round numbers or even whole numbers, but once you start getting into fractions and decimals, there's literally an infinite number of possibilities that you could have for answers. And this technique can be very, very complicated if you have to go through that many steps. So let's do something like this. Let's try and solve this algebraically. Let me lock this guy in. And what would this look like? It would look like this. We would take 90 plus 82 plus 81 plus 2x's. All of that divided by 5 has to give us 80%, which would be 86 out of 100. So let's solve this by combining like terms. What is 90 plus 82 plus 81? I think that was 253, right? Yes. So 253 plus 2x's over 5 is supposed to be equal to 86 over 100. So when we cross multiply here, this is where it gets a little tricky. This is going to require distributive property. So it's going to be 25300 plus 200x is going to be equal to 200, what is that, 430? 430. So now let's, oh, is that really right? Is that right? It's got to be right. No, it doesn't have to be right. What has gone on here? Hold on for a second. All right, I figured out my mistake. See, this is why we record our work and we think about the math. I made a bit of an error here. 86%, we're going to write that as 86 over 1, right? Because it's not 0.86%. I mean, it kind of is, but no, in this particular situation, let's revert this back to here. This 253 plus 2x, and now when I subtract 253 from each side, 253, what do we get? That cancels out, gives us 2x is equal to 430 minus, sorry about the sloppiness there, 430 minus 253 is 177, and now when I take 177 and divide it by 2, that's going to give me my x. What is 177 divided by 2? That is my answer. 88.5 is equal to x. So what did you think was easier, going through the guess and check process or solving this algebraically? Probably for you right now, the guess and check process, because that was a somewhat complicated algebra problem to solve, and we haven't really had a lot of practice with it. So that's why we learn the guess and check, because you can always fall back on that. All right, factor each expression. Remember, you're looking for the greatest common factor of each one of those terms. So they're both even numbers, so we know 2 goes into them. And it turns out 4 goes into them as well, because this is 4 times 21, and that's 4 times 5. That ends up being the greatest common factor. So if you divide each of these by 4, then you're going to get 5y minus 21. And remember, we don't get rid of the 4, we just factor it to the outside. And test that to make sure that when you send in the dive bombers, that you get back to the original expression, and it turns out that you do. So that is the answer. And then here, what do 24 and 96 have in common? Turns out they both have 24 in common. So we can divide each one of these terms by 24, but it also, yes. It also has a b in common, because b squared is b times b, and this is b times 1. So if you factor out a b as well, and that comes on the outside, no, yes. Okay, so 24 divided by 24, and then b squared divided by b is b, and then 96 divided by 24 is 4. Okay, this is kind of tricky. Not the easiest work to do, but I am not expecting you to have this mastered in 7th grade. Even in 8th grade, we work on it a little bit, but this is going to become very important in high school, in 9th grade algebra, when you start factoring quadratics and other trinomials, polynomials, if you will. And you have no idea what that means, and that's fine. Okay, so having problems, just go ahead and look at this. I apologize for that problem right there. Oh, actually, it's not that bad. You know, you got to add something to negative 4.2 to give you negative 3. So negative 3 minus a negative 4, you know that's got to be a positive, because this is greater than that. That could be a little bit tricky to know what to do there. Technically, negative 3 minus a negative 4.2 is going to result in KFC, and that's how you get your 1.2. And then once you know that's 1.2, multiply your decimal. So 12 times 42 is 504, and you got 2 decimal places, so you put that back into the answer, and it's a positive times a negative, so you get a negative for your answer. All right. I love, well, do I love them? Well, kind of, sort of. I used to teach 5th grade, And when we were doing fraction and percent problems, we used to create this as the visual to help us solve the problem. So let's start, and it's very, very much related to the diagram. It's just a different visual telling you the same thing. A cattle rancher gave 1/3 of his land to his son and kept the remaining 2/3. He kept 3/4 or 3/4 of the land to himself. So that means if you break this up into 3 equal parts, 2 of those 3 parts has a total sum of 34, right? So that means if you take this is 1/3, this is 1/3, and this is 1/3, and you take this 34 and you break it in half, that means those two have to be 17. And since they're broken up into equal parts, right? Thirds are all equal parts, that makes this have to be 17. So the total is 51 acres. So whether you choose to do it like this, if that makes more sense to you than doing it like this, then go ahead and do it this way. It's whatever way works for you. The bottom line is this: you're being graded on declaring the correct answer. So make sure you know how to get to that correct answer. And that is it for our homework. Hooray. All right, let's move on to the next activity. Take care. Bye.
Hey, feeling good